Okay. So in the last class, we completed data constraints, how to apply on your table columns along with table creation. We checked it out, right? Now, let me come out here. The next level is how to add constants on your existing table, so that you will see. But before that, as of now, whatever the constants we applied here, okay, whatever the constants we applied here on a particular table columns along with your, okay, table creation. Suppose you want to see it, so those constants information I want to view. So those constants information I want to view. So whenever you want to view the constants information, okay, whenever I want to view the constants information here, okay, how I can see the constants information on my table. So that means I have to know that which type of constraint I was applied on which type of column, yes or no. So this kind of information whenever you want to see it, okay, so there we have one topic here guys here, that is called as what now, data dictionaries. So data dictionaries, okay, or else even though we can say it is a, or else even though we can say it is a read only tables also we called, read only tables also we called, okay, data dictionaries or read only tables. Okay now, so what is this data dictionary and what is this read only table, why it is called as a read only table, and what purpose this data dictionaries are having means, simply we can see these data dictionaries are simply we called as it is some predefined tables guys here. Okay, these are simply we can say these are predefined tables. Okay, these are predefined tables, and these tables, okay, automatically inbuilt in your software. So whenever you want to installing your Oracle software, automatically some predefined tables also installing along with your software. Okay, along with your software. Okay, and these predefined tables, okay, are called as here, are called as here data dictionaries we called, data dictionaries we called, okay now, and data dictionaries we called. And now in this data dictionary tables, in this predefined tables or data dictionaries, table means it's storing some information, right? Table means storing some information. Okay, table means storing some information. Okay, so now which kind of information will be stored means it was storing, it was going to be, so these data dictionaries are storing, dictionaries are storing the information, storing the information, okay, information which is related to, which is related to database objects, which is related to database objects. So data dictionaries are used to store the information about the database objects, otherwise information which are related to database objects like okay, objects like what is here, like tables information, okay, like views information, like synonyms information. Okay, what is synonym, what is view, that all we will discuss, don't worry. So indexes information, like we can go for constants information, like we can go for procedures informations, like we can go for functions information. So like this, every database object, every database object related informations are storing under data dictionaries. Okay now, storing under data dictionaries. So data dictionaries are nothing but what now, it was going to be stored the information which is related to, the information which is related to, okay now, database objects like tables, views, synonyms, clusters, indexes, partitions, procedures, functions, triggers, packages. So whatever it was there, okay, so that all database objects information we can store it. Yes, okay now. So that is what we called as, okay now. But here these data dictionaries are, okay, not only, okay, whatever the data dictionaries are there, predefined tables, on these tables we cannot perform, we cannot perform, we cannot perform DML operations guys. So DML operations means on these tables, we can't perform insert, we can't perform update, we can't perform delete. So these kind of operations are we cannot performing on this data dictionaries. Understand my point now? So we cannot perform in data dictionaries because okay, it is only for supporting. Okay, these are supporting only one command. That command is called as a select command only support. Okay, select command only supported, and select command purpose is what now? We are using select command for which purpose? Reading purpose. We are using which purpose? Reading purpose. Yes or no? So that's why these data dictionaries or these predefined tables are called as a read-only tables we call. What we call guys here? Read-only tables we call. Okay na? Right. So because on these tables you cannot insert, you cannot update, you cannot delete, so that means we cannot manipulating the data dictionary tables data, we cannot manipulate, we cannot modify. It's only select command, and select command through we just reading purpose only it was used. So that's why these tables are called as a reading or read only tables also we call. Okay, so like this here guys, here every object like a tables. So tables information storing, or okay, suppose for example tables, so tables information storing under one data dictionary, like a views, like a views, so views information storing under another data dictionary, like a synonyms, synonyms storing purpose we have one more data dictionary, like we can store our constants information, constants information storing purpose one more dictionary. So like this every database related objects information, every database related objects information storing under one separate data dictionaries, one separate data dictionaries. So like this there are so many data dictionaries are available in our Oracle. There are so many data dictionaries are available in our Oracle. Okay, now so these are all data dictionaries. Okay, if you want to view all data dictionaries, all data dictionaries, okay, dictionaries, okay, in in Oracle database, then we have a one small syntax is there guys here. So that is syntax will be, the syntax will be select the star from dick. Select a star from dick. By using of this we can see all data dictionaries, okay, in our Oracle. Okay, let you see, I will show you how many data dictionaries are there in our Oracle database. Okay, now I'm passing select a star from dick. Okay, now you can see. Okay, so can you see like almost 1873 so data dictionaries are available. These are all are called as a read-only tables. On these tables we cannot perform any DML operations and we can use only select command. Okay, so that means every data dictionary is storing some specific object related information guys. Okay, now that's why what it was happened, so many data dictionaries are there in the system. Okay, because every related information is going to be stored here in separately. Okay, right. So like this, in this data dictionary, so many are there. Okay. Now let me see here. Suppose, okay. Now in the previous classes we applied constants. There are different constants we apply, like unique, not null, check, primary, foreign key. So these constants we applied on your table columns. So now I want to know it on a particular table, which type of constants I was applied, or else on this table constants are there or not there. So this kind of information, whenever you want to view it, so like how to view the constants information on a particular table, let me see it now. Suppose if we want to view, okay, for example, suppose if I want to view, okay, if we want to view constant name, and okay, constant name along with the column name, of, or in a particular table, in a particular table, okay, then we use one data dictionary. Is called as user underscore cons underscore columns. So user underscore cons underscore columns. So this is one data dictionary, guys. Here, with the help of this data dictionary table, I can see on a particular table on which column, which type of constant I was applied. So that information I can see it. Okay, now, so let me see. For example, come to your database. So previously, so many tables we designed in our database. Okay, like we designed this. Now, so we applied test 1, test 2, 3, 4, 5, 6, DEPT1, EMP1, 2, EMP2. So these are so many tables we designed in the last class for our constants using purpose. Okay, now, suppose one of my table test 2. On test 2, which type of constant I was applied? On test 3, which type of constant? Test 4. Okay, test 4, test 5, test 6, EMP1, DEPT1. So any one table you can choose and any one table you can take and you want to see on these tables, we have which type of constant the user is applied. So that information I want to see it here. So whenever you want to view like this, then I have to write here, what is my data dictionary? User underscore cons underscore columns. Okay, so it is a one of the data dictionary. So it's like a table. Now, first of all, I want to see the table structure. Now, desk, how you are seeing the table structure, same as usual. We can apply your desk. Okay, user underscore cons underscore columns and to execute. So in this, we have some column names. Let you see, it's the same look like a table structure, right? It's the same look like a table structure, right? Yes, it's same look like a table structure. Okay, now, right. So in this table structure, these are what now column names. Okay, these are some columns are accepting null or not null and data types here. Okay, so now in this, where the important columns here, what constant underscore name, table and column. So these 3 columns I'm calling now. Okay, 3 columns I'm calling. Select column underscore name. Next I'm calling second column constant underscore name. Okay, from which table? From which table? User underscore cons underscore columns data dictionary table. Columns data dictionary table. Okay, now and where which table you want to see. So that is called it where table underscore name is equal. So suppose I want to call it test number 2 table, for example. On test number 2 table, let you see is there constants we having or not. Let you check. Yes. So now test number 2 table. So above one is column name, below one is a constant name. So column name is a name. On name, one constant we applied. So that constant name is sys underscore C00 C101, and this sys serial number column sys underscore C006101. Okay, but here what it was happening here, column name is we can understand column name, okay, so and so column name in my table. But constant name, when you come to constant name, it was giving some number, sys underscore some number, sys underscore some number. So whenever it was having the numbers, we cannot understand that by seeing of this number, by seeing of this constant key number, we cannot understand this is which type of constant. Okay, so by seeing of this number, this is which type of constant that we can't say it, whether it is a unique constant or ordinal constant or check constant or primary key constant or foreign key constant. So which constant, which type of constant? So that is we don't know. That is we don't know. So because of reason why, sir, the user cannot understand the constant means, here these constant names are defined and created by system. Defined and created by who? System. SYS, SYS. SYS means system defined constant key names. System defined constant key names. For example, let you see. Suppose DEPT1 table yesterday we created. On DEPT1 table, primary key we applied on department number column, right? But you can see the primary key constant name is sys underscore C006108. So because these are system defined constant names, so that's why system is giving some ID numbers. But by seeing of this ID number, can you identify it, guys? Can you identify? This is which type of constant can you identify? Come on, guys. By seeing of sys underscore C0061, some number is there now. Can you identify this is which type of constant? The user can understand. Yes, user cannot understand. So suddenly, one new user is came. I'm showing to that user, so he cannot understand. I don't know, sir. This is which constant? Is it a primary? Is it a foreign? Is it a unique? Is it a null? Is it a checker? We don't know. So why user cannot understand means this is not a user understandable format. This is not a user understandable format, right? So that's why we can't understand what and which type of constant. Okay, because it's created by system and system defined. So like this, you can see your constants information by using of dictionaries. By using of dictionaries. But here, the problem is what now? Previously, whatever the constants we applied here, those are all constants that we applied on along with the table creation we applied. So that's why user is not created any user defined constant key names are not defined by user. That's why by default internally system is going to be created. Okay, see, I'm showing one example again. Observe. For example, guys, create a table test number. For example, how much you are 7. For example, test number 8. Okay, now right. Suppose serial number integer. I was applied unique. I was applied unique. Suppose some name I'm going to take in varchar or otherwise serial number I was applied your primary key, comma, some name I was taking your varchar 2 of some size, and here I applied unique. So here what I'm going to do here, along with my table creation, I was used my constant. So on serial number, primary key is applied, name column, unique constant is applied. Okay, fine. Table is created. But in this table, what are the constants we applied here? Those constants now I want to see then I have to use this data dictionary user underscore cons underscore columns, where table underscore name is equals to, what is our table underscore name? Test number 8. Now we can see what happened. Yes. So now we are seeing our constraints. Okay, name and column name, constant name. It is visible, that is showing us. But tell me, guys, this constant name created by who? System. So system defined constant key names. But by seeing of this number, can you identify which is primary key and which is the foreign key? Which is primary key and which is unique constant? Can you identify? No. So we cannot identify. I'm very confusing here. Which number belongs to which constant? Which number is belongs to which constant? We don't know. It's a confusing to me. So this is what the system defined. For example, sir, user defined, I have to give it now. User defined, how to give it here? Observers. Suppose you need to create a user defined constant key names I want to create. Whenever you want to create a user defined constant key name, what is our syntax? Can you see? Create a table. So I'm passing here table name of column name 1 and suitable data type of a size if required size. Okay, size is required size. Understand my point? Okay. After that, can you see size? After size here, what I want to do, I'm going to give here constant is a predefined statement or predefined statement. Later, I want to send user defined constant key name, user defined constant key name. Okay. Now, after that, you can apply your constant type. After that, you can apply constant type, comma. Next, column number 2, suitable data type, size. Same here also, constant is a predefined statement. User defined constant key name. Okay, and later key name, and later I want to apply constant type. Okay, comma, and so on. Okay, so and so on. Like here, what is here? Previously what we did, column name, data type, and directly constant type we applied. But we are not using constant user defined constant key name. The statement is not used in the previous. And now we can see along with this what it was happening. Let you come out. This is a normal, see, normally column name, data type, and constant type is applied here directly. Now I'm creating one more new table. Can you see? Create a table test number 9. Now I want to take EID int data type is given. After that, constant is a predefined statement. Later, user defined key. User defined key means my wish. I want to give my own name, which is understandable to the users. Okay, suppose I'm giving like EID underscore PK. So that means on EID column, the user is applying primary key constant. So this is user understandable. Otherwise, you can give like this. Your name is also, your name you can give Suresh. Okay. Otherwise, you can give any XYZ. What is, that means user understandable format. When I see any user, if any user, not only this is created by Sudhakar sir, it is created by Sudhakar, but other user can also see my table. Okay, they can understand that, okay, Sudhakar sir applied so-and-so constant on so-and-so column. So other users also, they can easily understand to me what I did apply, what I was applied with. Yes, sir. So that's why for all user understandable format, here I'm taking EID. EID underscore PK. So by seeing of EID underscore PK, if any user can see this constant key name, they can understand that, okay, on EID column, we applied primary key constant. So that is an indication to identification to the users. Which type of constant are you applied on a column? That identification purpose, you need to create our user defined constant key names. Now I was given. After constant user defined, now I want to give my what? Which one I want to give? Primary key. In the same to same name, where get to of some size. So here also I need to apply constant. Suppose I'm taking here e name underscore UQ. UQ means unique. Okay, and later my constant type is what now? My constant type is what now? unique. Okay, now? So like this. Suppose if I created like this, what happened? You can see your table is successfully created. After table creation like this, now let you call. Now I want to see my constant name along with the column in a particular table. What is my table number? Test number 9. Let you see to execute now. So now you can tell me, guys. The above one is a column name, below one is constant name. Can you see? So EID column. On EID column, which type of constant I was applied? Primary. E-name column, I was applied which type of constant? UQ. So now tell me, now it is understandable? Come on, guys. Now tell me it is understandable? If any user can understand which type of constant I was used here, which type of constant I was applied on which column? Okay, can you understand now? So identification is very easy. Are you identifying easily? Okay, now? So that means what happened? See, here, this is system defined constant names. Here, user defined constant names. So now which is better to understand, guys? System defined or user defined? Which one we can easily understand? Which one we can easily understand? User defined or system defined? Yes, good catching my point. Good catching my point. So now this is the way user defined constant key names are created by programmer on your table column at the time of constant is applied. So that is what is the syntax I was given. This is the syntax. Okay, now this is the formula. So whenever you want to create your user defined constant key names, okay, which type of constant are you applying on which type of column in a particular table? So that was you want to show the user understandable format. Then you just follow this syntax. You just follow this syntax. Okay, now user defined. Okay, now so this is advantage of what now user defined constant key names. How to create means this formula, this is a predefined formula. This formula you just follow it. Okay, now by using of this formula only user can creating its own names, okay, on your constants, okay, on a particular column. Okay, now see how much easy now. So not only myself, this table was designed, test number 9 table designed by user. Okay, now, but after designing whatever I was given the constant name on my columns, then anybody can come and open my table structure. They can open table and they can see, okay, Sudhakar sir was applied primary key constant on EID column, unique constant on e-name column. So that is clearly, easily identification. But if I'm going to like this here, if I'm going to like this here, suppose if any other user is come out, he can't understand Sudhakar sir, which constant is applied serial number, which constant is applied name column. User cannot understand because you're having number. You're having number, the which number is belongs to which constant we don't know. So that's why your confusion is occur. Identification of constant is difficult here. But here, identification of constant, which constant you applied, that is easy. So this is user-defined advantage. Okay, and real time also, when you go for real time also, they're preparing like this only. They're preparing like this only in real time because the users can understand easily which type of constraint are you applied on which type of column. That information anybody can easily identify, anybody can easily understand. So that's why they are following some user defined case. That means I'm not saying that this is wrong. I'm not saying that this is wrong. See, here creation of table directly what it did a serial number, data type, primary key. That's it. So here just I'm giving primary key. That means just I'm giving constant type name I'm giving, but key name I'm not giving. That's why whenever user is not defined key name, then automatically system is created. Then automatic system is created. So now we can see carefully. Now we can see carefully the creation of you can see carefully the creation of See, here system defined constant key names are how it was created on my constant. And this table and that table, you just observe. Difference you can understand. You just observe. Difference you can understand. You just observe. Difference you can understand. Okay, now here what I did, here what I did, you see, here column name, here also column name, data type. But after that, directly I'm giving constant type. But here I'm using what? Constant is a predefined statement, constant key name. Okay, after that, I was used here primary key. Understanding now? So this is user defined, this is system defined. Because user is not mentioned any constant name, user is not mentioned any constant name. So that's why system is created automatically. That is this one. That is this one. Understanding now? But here user is created. This is user defined. That's why, so whatever the name I was given, that name is showing here. This is user defined, this is system. And syntax is also difference. Okay. So now understand now, user defined constant key names. Why should we want to create, sir? User defined constant key names. Why should we want to create, sir? Means to understanding, to identification purpose. Okay, right. So this kind of information is storing under one data dictionary. So my data dictionary name is what now? User underscore cons underscore columns. So that means with the help of this data dictionary, I can see the constants information. Which type of constants are you applying on which type of column in a particular table? So that information I can see it by the help of user underscore cons underscore columns data dictionary. Okay, no? So user defined constant names, how to create, now understand now? Right. And after, see, for example, suppose test 9 table is created. ID and name is there. Let you, I'm inserting now. So insert into test number 9, sending values of suppose 1 comma a I was insert. The same thing when I'm sending here, observe test number 9, 1 comma b I'm inserting. But here EID column is a which type of constant is there? Primary key. Primary keys duplicates are not allowed. Let you see error. But you can see error is rising here. But what is, come on, what is my constant key name? Come on guys, which constant is fired? Which constant is fired? Unique constant is fired or primary key constant is fired? Yes, PK was fired. So that is also I can easily understand because in my table, so many constants I applied. But on which column my problem is there, which constant is firing means, that also I can understand by using of system defined. Okay, now in the same, suppose I'm passing here 2 comma a. If I send here, it's a clearly telling that e name unique constant is violated. See, user defined names, how it was showing easily. Understand my point now? Are you getting my point now? User defined constant key names, advantages you can see. Easily we can understand. Okay. But the same thing, this is test number 9. Test number 8 is also there now. This is test number 8 is also there now. Where is my test number 8? Yeah, this is test number 8. Here just a prime.
Progress.
Constant is what? Predefined statement. It's a predefined statement. Add a constant. And here I want to give constant key name. Okay, I want to give constant key name, and after that I need to type your constant type I want to give, constant type I want to give, and just constant type of which column name. Okay, right. So this is the syntax how to add constants to an existing table. Let you see one by one. I will show. First one I'm showing you, adding primary key, pk, adding primary key. Let you come out, let you come out, carefully observe. Now first of all, one table I'm designing here, guys. Create a table name is parent, table name is parent of some. I will take here some serial number, integer, some name, varchar 2 of some size, salary, some number of some size. And now table is created, table is created. But tell me guys here, on when I'm creating my parent table, okay, I was applied any constants on this table, guys? No, there is no constant, right? Suppose you have a doubt, you can see your data dictionary, user underscore, cons underscore, columns, and now I'm calling column underscore name, comma, constant underscore name from user underscore, cons underscore, columns, okay, now where table underscore name is equals to parent. Name is equals to parent. Let you see now, there is no constant on this table. It's a clearly showing us. It's a clearly showing us on your parent table. There is no constant names, so there is no rows assigned. So, are you catching my point? Come on, guys. Are you catching my point? So, are you catching my point now? Yes. So now on this table, there is no constant. Let me see one by one we are applying it. Okay, first I'm applying primary key. So now I'm applying alter. So table name is what? Parent. Add what I need to add a constant. And constant key name I want to give. Okay, fine. I'm giving constant key name. For example, pk underscore serial number. Okay, now then after my constant type primary key of serial number and to execute. So table successfully altered. Table successfully altered. And let you see now your constant successfully adding or not. Suppose you want to see, then you can go for this data dictionary to execute now. Yes. Come on, guys. Are you adding your primary key constant on serial number column? Come on, yes or no? Okay, now, right? Successfully, we added primary. Like in the same to same, remaining constants also I'm applying. Like next one is what now? Alter table. Table name is parent. Add constant and constant key name. For example, UQ underscore name column. Then constant name is unique of a name column. Yes, successfully. Let you come out. Let you come out. Yes. Second constant we applied on name column, right? Now, in the same to same, next alter table. The table name is what? Parent. Add constant. Okay, constant. Constant key name CHK underscore SAT. And I'm applying check of salary, which is greater than 5,000. The check condition I'm going to adding. Now let you see your check constant also successfully added. Yes, of course. Yes, of course. So check constantly applied. Like in the same to same, not null. But not null, whenever you want to apply, some little bit the syntax will be changed. Okay, syntax to add, what is this? Not null. Little bit change. The way it is changed, observe. Alter table, table name, and here not null. That means we all of you know this. By default, every column is accepting null. Yes or no? Come on, guys. By default, in your database, by default, your column is accepting null. Yes, null. That already we know this. So that null, I'm going to converting into not null. Already by default, null is there. Every column is accepting null. So that I need to convert into not null. So that's why here what I'm using here, I'm using modify keyword because null to not null, I'm changing. Okay, I'm changing. Here I'm not adding. I'm just changing null to not null. That's why I'm using modify. So modify and which column, that column name I need to send. Syntax will be different. Observe column name. Which column? Then what we need to use? Predefined statement constant and constant key name compulsory. We should give it here as usual. Constant key name, and after that you have to apply not null. This is not null constant. Okay. So alter table, table name, modified column name, constant predefined statement, constant key name, and finally not. Let you see, I'm going to apply here, for example, alter, same syntax I follow. Alter table name is what now? Parent. Okay, parent, and I'm using which key modifier. Which column? Suppose salary column. Suppose salary column name, constant key name, salary underscore NN. NN means not null. And finally, I'm giving not null statement. I'm giving table successfully altered. Okay, now. So here what happened? Okay, so now successfully we alter because why I'm not using admins as of now we discussed na Sanjay. Where are you here? Are you there in the classroom or not? As of now, why I'm discussing? Why I'm using modify? I said na. Again, you're asking same question to me. Are you not there in the classroom? What we said, why I'm using your modify keyword means then you're why are you asking this question? Already I was given an answer. What I said, why I'm using modify, I said because by default your columns are taking nulls. By default your columns are taking nulls. So those nulls I want to convert into not null. Convert means what? Now change. Change means what? Now modify. Again you are asking why it should not be take add rather modify. Huh? Again your same question is asking. That's why explanation time, whatever I'm delivering my words and my sentence, focus on that, guys. It's a clearly given. Why I'm using modify means reason is what now? By default, your columns are taking null values. That null we need to change as a not null. That's why you're not using add keyword. Here I'm not adding, I'm changing. That's why the people was given modify. And one more thing, all of you remember, these syntaxes are Sudhakars are not created. I am not invited this. Understand now? This is a predefined syntaxes, which was given by Mr. E. F. Cott, scientist. Why like this? Why not like this? Means a plus b all square, formula a square plus b square plus 2ab. Why like this? If I'm asking question to you, what happened? What is your answer? Why a plus b whole square formula a square plus b square plus 2ab? Why not a square minus b square minus 2ab? That is called a cross questions. Because already scientist was given that predefined formulas here. My point, understand here in database, everything is a predefined formulas. Okay, now, are you understanding my point? Everything is a predefined formulas. Right? So that is a point. So I am not designing this one, guys. First thing is what now? I am not designing, even though nobody, Java is there. Java, so many faculties are teaching to you. So Java, how the people was designed, same thing teaching by faculty or trainer. If I have a 15 years of experience in Java, can I change Java formula? That point, that's why again I'm giving what explanation also. Why the scientist was taken modify keyword means, why not add keyword means, here by default columns are accepting nulls. So those nulls are, we are changing into not null. So changing, we are not adding here, we are changing. Understand now? The clarification also given by scientist, why he was taken modified. Okay, right. So that's why every point is very important here. Don't think that I'm not writing my own anything. Everything I just following formulas, which was given by people, which was given by scientists. Column is different, constant is different. Yeah, column is different, constant is different. Okay, now. If you like this now, then I'm also argue like this. Why not a plus b whole square, a square minus b square minus 2ab? Like now, this is called a nonsense argument. That is called a time waste arguments. These are. Understand? Right. So see, some predefined things are there. Those we can't change it, guys. So that's first thing is understand. Okay, now first thing what I'm telling, any technology, not only database. Are you learning Java, Python, any technology? So there's specific rules they followed by scientists. As per their rules and as per their analysis, they're designing some syntaxes and specifications in their languages. My point, understand? That means, see, different technologies, different scientists, different ways they was designing their technologies. Suppose you are a scientist now. Suppose you want to invite any new thing. So as per your analysis, you are going to be designing. Yes or no? So you're going to be what we can say, you're testing, you're doing some experiments. Okay, these are all the things you finally got one formula, and the formula you're telling that this is my formula. I was invited, right? So that is what I'm telling. Okay, now that's why here anybody, even though Java faculties, .NET faculties, any technology, any trainer, everyone they will follow the predefined things only. They have not created any new things. Already technology is existing technology. That existing technology, I am teaching to you as per my experience, because I have some experience in this subject. Yes or no? That is what teacher. Okay, I am not a scientist. I'm a teacher. Scientist different, teacher is different. Right? Yes, that's why Sanjay, that's why you're asking, okay, but before asking that question, I already given that explanation. Again, you are asking. That's why I'm asking, are you there in the classroom or not? You are asking correct. I'm not saying right or wrong, but what I'm saying, already that point, on that point, I was given explanation already. Why not add? Why we want to modify? That is your question. That already given explanation. Again, you're asking to me. That means you are not there in the classroom. Huh? Or otherwise, you are not listening my words, sir. Tell me. You are only asking that question. Why not other people are asking? Because other people are focusing on my explanation. I already given answer. Right? That is what. That is what. Okay, so now what you understand? Modify why the people was given means, the scientist was given means, reason is what now? By default, every column is accepting null. That null I'm going to, we are going to changing. Yes or no? We are going to changing. So that's why changing means what now? Modify. That's why you are using scientist. You are using scientist what? Which keyword? Modify keyword is used. Okay, now? Right. So now, okay, successfully we modify. So not null is changing null to not null, right? And let you see whether it is modified or not. Let you see. Yes. So salary underscore NN. So that means now salary column is not accepting null. Okay, now. So now we can say, I will show you everything practical. I will show you. Don't hurry. Observe. Okay, guys. Now here parent table. So on parent table, I was applied total 4 constants are we used here. Okay, right. Let me test now. Let me test now. I'm testing now. Okay, I'm testing. So insert into the table name is what now? Parent. Sending values of serial number. Okay, for example, serial number 1, some name, Sai, salary. See here, salary. What is the condition of salary I was given here? Salary must and should be greater than 5,000, right? Okay, let you come, let you come. Okay, now I'm giving here 6,000. And salary 6,000. Okay, 3. Okay, fine. So now what happened? This is my first record. I hope that all are satisfied as per the given conditions. So this row successfully created. Right? Now we can see, the second record I'm inserting. Now careful observe. Here you can observe, you can observe, you can understand. Again, I'm giving 1. Okay, fine. Some name I'm passing Adams. Some salary I was given here 7,500. Okay, now. But guys, here serial number, which constant serial number? Primary key. On serial number, which constant we applied? Primary key. So primary key is accepted duplicate data. Come on, guys. Primary key is accepted duplicate data? No. So that means now whatever I am adding primary key, that should be rise now. Yes or no? If our requirement, if our adding constant is right means whatever I was inserting duplicate data at this point of time, that primary key should be rise. So now rising or not, you can see. Yes. So we are sending 1. What it was rising here? Your unique constant is violated, and the constant key name is what now? PK underscore serial number. So now tell me your primary key is working now. Come on, guys. Whatever we adding our constant, that constant is working now. Yes. Okay. Like this, we will test all constants. Let you test. Let you test. Now 2, comma. I'm giving Sai. 2, comma Sai, and salary is 7,500. But here the problem is Sai I already inserted into my table, but on that unique constant we apply. So unique constant also duplicates are not allowed. This time unique constant is violated. This time unique constant is violated. Okay, that is also working fine. So now different number, different name I'm giving, that's fine. Now I'm giving here 5,000, I'm giving exactly. Now 5,000 is accepted. As per our condition, what? 5,000 greater than 5,000. Greater than 5,000, right? Now I'm giving 5,000. So will you accept this? Not at all. So now which one? Check constant is raised. So my check constant is raised. Check underscore stand. Okay. Now to this same salary column, let you see 2. I'm giving Adams. I'm passing null now. Now tell me, salary column accepting null? No, not at all. Why? Why? Because Yes, because what? Yes, not null we use it there. So that's why when I'm using null, if you say it was showing error, which one? Which one is showing here? Null cannot insert null into spot parent salary column. Understanding? So null is not allowed. Suppose this constant is removed now, then null is allowed. Yes, sir? So that means whatever we applied here, these all constants are working now. Come on, guys, working or not? All are working. Right. So this is how to add your constant or apply your constants. Okay. In the same to same, foreign keys also I can apply. Again, foreign keys also having a different syntax. See, whenever different syntaxes are coming out, I'm showing before only. Okay, now understanding my point now? Says not null, different. That's why I'm showing not null how to add. Okay, primary, unique, and check same syntax adding, but not only again different. Again, foreign key is also same, but little bit different. The syntax formulas. So what is the differences? You can carefully observe. Syntax to add foreign key. If same syntax means I don't want to write multiple times. Yes or no? Whenever it is different, there I'm using here. Okay, now we can see alter table name, add constant is a predefined statement, and later I need to give my constant key name. So as usual, so where it is different, carefully observe. Constant key name, and after that, I need to apply foreign key. I need to apply foreign key of, here I want to use common column of a child table because we are applying foreign key on child table. Yes, the common column, whatever you taken, that you have to give it. And later what I'm taking here, references. Say references. Are you taking references from which table? Parent table. So I want to give parent table name of what is that? Common column of a parent table. Okay, now syntax careful observe. After that, you need to apply the two things we applied. Okay, on delete cascade if you want to add, otherwise on delete set null. This is the syntax of your foreign key. So are we identified now how the syntaxes will be variation as per the constants? Okay, now right. So this is the way of adding foreign key constant, and we should follow this one only. There is no other way. There is no other alternative way. I should follow this one only. Whenever we are applying or adding foreign key on existing table, right? Let you see. Let you see. Come back. Oh, okay. Now I'm creating one more new table. The new table name is child. Some department name varchar2 and the common column. Which column I have to take common column means which one I was taken serial number now. My primary key column serial number. So serial number is a common column, same data type. Because serial number is in my parent table, serial number is a primary key table, right? Right. So now primary key column, right? Now I just go. Okay, fine. Now I need to add a foreign key. So how to add alter table? The table name is child. I'm using add constant key name serial number underscore fk. Okay, serial number underscore fk. And now I want to use constant type. What is a constant type? Foreign key of common column. What is a common column? Common column of child table serial number. Okay, now what I need to take references. Are you taking from references from which table? Parent table. My parent table name is parent. Parent of which column? Same common column. Suppose you need to apply. Suppose you need to apply on delete cascade. Okay, apply. So on delete cascade, on delete set null, any one only we can apply. Not at a time both. I already said to you in the last class also. So if you want to apply set null, you can apply set null. You can apply cascade, you can apply cascade, right? So now I let you see what happened. Yes, table successfully altered. And let you see on this child table, your constant is added or not means same data dictionary. I just follow it. Okay, same data dictionary. I should follow it. But here in place of parent, which table now I want to see child table? Let you see. Yes, serial number FK. So your child table successfully we applied a foreign key. Okay, now come on. Now let me see parent table and child table successfully we designed. So parent table, this is already some data was there. Okay, now and now some more information I'm inserting into my parent. Okay, let you see. That is also I'm testing whether relationships are happening or not. I'm testing now. So serial number 2, the name is what now? Adams, and the amount of salary 7,500. Okay, fine, and to execute. So after this, finally come back to your parent table. Your parent table is having two parents details. One is Sai and Adams. Now come to my child table, but unfortunately in child table there is no records, right? Now I'm inserting. But what we said, whenever you want to insert data or values into child table, those values must and should be primary key values only. Okay, now insert into child table, sending values, department name B1 and 1. So 1 can I accept, guys? Can I accept 1? Yes, we can, because 1 is there in the parent table primary key column. So 1 successfully accepted. Same pattern, I'm going to here depart D2 and 1. Can I accept? Yes, I can. Now D3, I'm taking 2. Can I accept? Yes. Now next one, D4, I'm taking 3. Can I accept? Yes. Okay, now right. So D4, 3, but 3 is not accepted as per our relationship. As per relationship, what it was, rule is there. Which rule is there? Foreign key values are must be primary key values only. That is a rule of a relationship. If that rule is breaking, means your relation is not correct. If the rule is breaking, means your relation is not correct. That means your relation is not established. Let you see whether it is accepted or not. Yes, it is not allowed. So integrity constant is violated. Where it is violated? Serial number underscore FK column. Why it is violated? Because the parent key is not found. Okay, no? So as per relationship, it was right. Okay, let you come out. Let you come out now your parent table. Okay, let you come out your child table. Right. Okay, now. But what we said, okay. So what we can say, unreferenced values. That means the value which is not there in the primary key, that is not allowed. Those satisfied. That we said no parent, no child. Okay, now. So that is our first rule also. Without the parent, no children's. Bina parents, impossible to make a child. Okay, now. Right. So that was satisfied. Second rule is what now? Deletion rule. Delete from parent table where serial number is 1. So now tell me your parent data deleted or not? Come on, guys. Not deleted. Huh? Hey, guys, I already applied on delete cascade. On delete cascade, I was applied. Last session only, I think yesterday only we discussed, I think, not yesterday only we discussed, I think so. Deleted now? Yes, definitely. Yes, definitely deleted because cascade is applied now. Yes. Now let you see parent table 1 is deleted or not? Yes, successfully we deleted. Okay, now? Right. So, but on delete cascade rule, what it was telling us? What it was telling us? Once parent is deleted, automatically child also deleted. Yes or no? Once parent is deleted, automatically child also deleted. Right, good catching my point. Let you see your child table. Let you see your child table. Okay, so child is also deleted. Deleted na? Yes. Okay na? So now, so successfully, now we are adding all constraints, how to add on your existing table structure. Okay, now this is one way of a constant phase, how to add. So how we are adding constant now on your existing table in the same to same pattern, I can delete now. How I was applied in the same pattern, I want to delete now. Then how to delete constants from your table? Yeah, delete is nothing but dropping. Okay now. So how to drop constants from existing table columns? Okay. So that mechanism we will see in tomorrow's session, guys. Okay now. So tomorrow we will go for the next level of mechanisms on constants. Okay. Right, guys. Thank you. Thank you so much.